Hey, Mum, Dad, come on, it's Spring Watch!
Oh.
Our favourite programme! Oh, isn't this great?
Yes!
Been waiting all year
There
for
you
this. Great bit of social learning we're going to be doing here, isn't it?
Social learning,
Yes.
Welcome to Easter 2060.
Hang on.
Coming to you from
Social
the wonderful
learning?
National Trust.
Shit!
South Pole
My video! Sorry! Have a good time! Bye!
Absolutely stunning, and look, Chris, it's a lovely day for us too.
Hello, thought I'd make a different entrance and welcome! It's the next instalment of the Acquisition of Behaviour series. Now today, we're going to move on a little bit. We're going to move on to social learning. So this is how animals use public information and use it in social learning. Now in the natural environment, there's two types of public information. There's intentional and unintentional information, right? Now great examples of intentional information are things like the waggle dance in honeybees. When the bees come back to the hive, they do a nice little dance, signalling the distance and at what angle away from the sun are particular good food sources. And we'll come on to that in a whole lot more detail in a later video. Another fantastic example, which we'll cover in a later video, is in vervet monkeys, which have specific alarm calls for specific types of predators. Right? Fantastic stuff. But what about unintentional information? Well, unintentional information can be acquired through eavesdropping. Let's be honest, we've all done it at some point in our lives because we're just naturally nosy. But it's a lot more important. It's a life or death situation in the natural world. And a great example is in the Tungara frog, which has a specific sexually selected call which it uses to attract females. That's what the males do anyway. And this is how it goes. It goes, chuck, right? Now it's the chuck bit which really gets the females excited because they respond better to deeper sounds, and the chuck bit is deeper. But unfortunately, it's the bit that predators also respond to a lot more because it's deeper, and these predators are bats, right? So these bats, such as the fringe-lip bat, can tune in to these chuck calls and help them pinpoint a nice frog meal, and then they're a goner, right? So you have sexual selection for reproductive success versus natural selection for survival success, fighting against each other here, right? Now, a great experiment on another organism to show eavesdropping was done in the lab on Siamese fighting fish, right? Now, Siamese fighting fish, the males like to fight each other to compete for females. So an experiment was done where Siamese fighting fish were kept in a tank and they were allowed to observe another pair fighting, right? A sort of one-way mirror was used, so the fish fighting couldn't see the one observing, right? Does that make sense? And as a control, they used fish where they couldn't see the other pair fighting. Okay, so two different experiments. Then what they did is that they introduced the fish that were fighting to the one that was observing, right? And they measured the latency in response. Basically, how quick that fish responded to the introduction of another fish. Well, they found that there was much greater latency if a male saw another male winning a particular fight. Right, which makes sense because they're like, oh god, he's a big tough guy, I'm not going near him, yeah? Yet if the fish didn't see anything at all, there's no difference, right? So there's clear eavesdropping going on here. Another great example is when looking at particularly good food resources, and the kings of these are birds called pied babblers, right? Which look where other people are finding great food and go there themselves, right? Cheeky little devils. So these are all examples of public information, and this can result in an immediate change in the behaviour of that animal, or it could result in social learning, right? And there's usually a trade-off going on, because this series is all about trade-offs between the extended use of public and private information. Okay, definition time. Right, what is social learning? Here it is. It's learning that is influenced by observation of or interaction with another animal or its products. Now, an important point to make here is that the demonstrator doesn't necessarily know that it's being a demonstrator, right? So it could be, another animal could just be eavesdropping, as we've been talking about, right? Another thing to point out is that social learning is not the same as social facilitation. So what's that? Well, I've got the definition here, and social facilitation is when the probability of performing a known behaviour increases in the presence of others doing it. And a great example is in cliff nesting birds, right? So as one kittiwake or whatever starts making a nest on the cliff, then it encourages all the others to do so as well. Because there's an advantage of doing that, because that means there's a greater chance of not being predated upon, right? By, mean birds like Arctic skuas and great black-backed gulls. Obviously there's some great advantages to social learning. It's less time consuming and less risky, because if you see another individual doing a particular task and getting away with it, then it's perfectly safe, right? So it's good at overcoming neophobia, a fear of new things. For example, experiments on crickets have shown that if a cricket sees another cricket being predated in a particular area, it will actively avoid going in that area, right? However, social learning isn't always done. In certain scenarios, social learning could be more time consuming than individual learning. Imagine just observing to see where your mates are, or waiting for your fellow bee to come back with a waggle dance. It may be better just to get out there and explore yourself and learn individually. It all depends on the ecology. Also, you could also be getting outdated information. If you see your mate Pie Babbler over there getting loads of food, then once you get to that place and learn that there's, good food there, the pie babblers before you might have scoffed a lot, so it would have been pointless. So there are occasions when individual learning can yield higher payoffs than social learning. Now another good tactic is to be a scrounger. Now I'm not, trying to promote this in everyday life, this is a natural world we're talking about here. Now, if you've ever been to North America, you'll be familiar with grackles. I'm half Mexican, so I'm kind of familiar with them. These are big crow-like creatures, quite pretty, but they're little buggers they are. They scrounge, they thieve off conspecifics, right? Now, as nice as it would be to do an experiment on grackles, here in the UK, we've only got pigeons, so we're going to have to deal with them for the moment. So an experiment was done on pigeons, right? And where they were kept in a cage, and there was a lever which they had to press, and if they pressed it, it would release food, right? Simple. So, in one experiment, there was a pigeon in the cage, and there was a mate right behind him, okay? Now, another point to make here is when the pigeon pulls the lever, it lets out a lot of food, right? You could say an excess of food, okay? In the second experiment, pigeons were just kept on their own. They had no mate with them, okay? And these pigeons on their own could observe each other, so they could see pigeons in other boxes with exactly the same situation, right? And they found that pigeons on their own, all of them learnt to press the lever, right? Whilst in pigeons where one had a mate, the one which didn't press the lever never learned to press the lever, because he was used to scrounging and feeding off the stuff which his best mate had already got for him. So what have we learned? Being a scrounger inhibits the ability to learn. Phew, what a life lesson. Okay, now there are several mechanisms of social learning, and in the next couple of videos we're going to be going through them. So the first one is local/stimulus enhancements. This is technically two. So local enhancement first is we're going to put in the context of our only endemic bird species, the Scottish crossbill, okay, which lives up in the Cairngorms in Scotland, believe it or not. Whoa, shocker! Another shocking piece of news for you is that these crossbills have crossed bills. I know, right? So their bills sort of go over like that, and they may look pretty silly, but they're actually specialists at eating and getting the seeds in pine cones, right? So, if another Scottish crossbill sees another Scottish crossbill feeding on a pine cone, right, then that crossbill may think, right, pine cones, oh, that pine cone looks like a great place to have my tea. So once that other crossbill is gone, he's going to come in and feast, right? So that's what local enhancement is. It's focusing on a specific place, right? Because you've seen another individual doing the same thing. So the presence and the behaviour of the demonstrator attracts the observer's attention, right? Now the difference between that and stimulus enhancement is when this stimulus is generalised. And that's what's really happening with the Scottish crossbills and the pine cones. It's much more common, right? So where these pine cones are generalised. So the crossbill has learned that, oh, all pine cones must be tasty and have lovely delicious seeds inside them now. Yeah? And we talked all about generalisation in the 6th video. Okay, so go back on that. But our third mechanism is observational conditioning. Conditioning! We love conditioning! Pavlov, Pavlov, Pavlov! Anyway, so that's when an individual associates a behaviour with a particular stimulus, right? Now, it's been a while since I had a good diagram on the whiteboard, isn't it? So I thought today had to be the day when a great diagram might have to return, and as you can see, what a fantastic work of art. Of course, you all know what it is. No? No? Oh well, I'll explain it anyway. So, it's a well-known fact that birds mob bigger birds, right? If you've ever seen a buzzard in the sky, I see it all the time, you see like blackbirds and crows flying around the buzzard and you think, what the hell are you doing? You're going to be dinner mates. Well no, they're ganging up on the buzzard trying to chase it away, right? They're very, very sensible. Safety in numbers and all that. And this mobbing behaviour was studied by Curio and his mates, because he was curious, on blackbirds. So these are blackbirds. Hang on. Yeah, they're blackbirds now. And they mob owls, right? So what happened was that they were kept in 2 different areas, and these 2 blackbirds were shown 2 different things, right? So they couldn't see each other, they could hear each other, but they couldn't see each other. They couldn't see what the other bird was looking at, right? So this bird was looking at an owl, a threat, right? Something which you might want to mob. This fella was looking at a milk bottle, right? Completely harmless. Well, having said that, milk bottles are very dangerous, as I found out to my own cost. What this blackbird does, he starts going crazy, he starts trying to mob this owl, right? Now, this blackbird can't see the owl, but he's going to copy him, so he's going to do, and that's our 4th mechanism of social learning, imitation, which we'll go on to in a second, right? So he'll start imitating, but whilst he's doing that, he's going to be associating the presence of the milk bottle with this mobbing behaviour. So as this blackbird grows up, he's gonna start mobbing completely harmless stimuli. Okay, so because he's been conditioned. Pavlovian conditioning. Imitation basically does what it says on the tin. It's when the observer copies the topography of the novel behaviour as demonstrated by a demonstrator. Right? Now this is something we'll go on to in more detail in the next video, so hold your horses for that one. Now our 5th one is probably our most complex one. It's goal emulation, and I've got the definition here. Okay, so goal emulation is where the observer attends to the movement of the object, not the behaviour of the demonstrator, and then comes up with its own solution to reach the goal, right? Now, that may not make much sense, but let's give it some context, and we're going to give it with a nice old wives' tale, right? So back in the 60s and 70s, in the south of England, people started to notice that 2 of our most common British birds, blue tits and great tits, started hammering away at the tops of milk bottles, right? Obviously, milk bottle tops are not as common anymore, so you don't see this behaviour anymore. Oh, what a shame. Would have been a nice thing to wake up to on a Sunday morning. But, you know, we can live a life full of regret. So these were chopping away at the tops of milk bottles, right? And they were thinking, why the hell was this? And this was only in the south of England. So the experiments were done on the American equivalent on black-capped chickadees, which are very similar to tits, right? By Sherry and Gallup. Instead of milk bottles, they used those little plastic tubs which have the milk in restaurants. Do you know what I mean? They never have enough milk in them, by the way. But anyway, there were three experiments done. So one where the chickadees were kept with no demonstrator, right, and the tubs weren't open, right? So this was the control experiment, right? So no demonstrator, tubs not open. Second experiment, there was no demonstrator, but the tubs were open, right? In the third experiment, there was a demonstrator opening the tubs, the demonstrator chickadee, opening the tubs in a separate cage, right, whilst the observer had closed tubs, okay? So what were the results? So here are the results. In the first group, where there was no demonstrator and the tubs weren't open, these birds never learned to open the tubs, right? However, it didn't give a damn monkey whether a demonstrator was there, because in both experiments 2 and 3, they both learned to open the tubs, okay? So it didn't matter whether a demonstrator was there or not. So therefore it was the tub that was generating this behaviour, not the demonstrator. So as long as the bird knows that there's a tasty reward to be had in that tub of milk or in that milk bottle, then it will learn how to access that milk individually. Now usually it will learn that there's a good reward to be had because they see another demonstrator opening it and they say, there's food there, right? But they learn to open the milk bottle by themselves. Now all we've talked about is vertebrates this video, and personally I feel sorry for the insects, so let's give them a go, shall we? So social learning in social insects. Well, surprisingly, there is social learning in social insects, and this is an experiment which we've kind of talked about before, but I thought it would be nice just to go over it again. So this was looking at how bees could use information given by conspecifics, right? So there was a box with loads of fake flowers on it, and on some of the flowers they stuck bees on them, dead bees, but the same species, right? The bees watching didn't know that they were dead, right? Okay, otherwise I'm sure they would have been hugely emotionally affected. But anyway, there were 4 experiments. So, first experiment was where there was a social cue which was informative. This was where the conspecifics were placed on fake flowers which had rewards in them. Okay? So it's telling the observers that were watching where these conspecifics were, it's telling them where to go. Okay? The second experiment was where the social cue was redundant. Okay? So this is where all the flowers had equal levels of rewards, okay? But the social cues, the conspecifics, were only put on some of them, okay? So here, the bees being there isn't really signalling anything, okay? Now, in the last 2 are the 2 controls. So this is where there was no social cue, so no conspecifics were put on the flowers at all. And in the 4th experiment, there was no learning phase. So there was no phase where the bees, the observers, were actually allowed to observe. So the bees were just chucked in at the deep end, completely naive. So they showed that when the social information was informative, the bees learned to visit that particular flower type. If it wasn't, if it was made redundant, it didn't affect it. Okay? Now, another experiment was done by Dyers and Chitka, our favourite 2 bee fanatics. And this was our example of second order conditioning in the 4th video, I believe. So there were 2 different flower types, green and orange. Green flowers had a lovely sucrose reward, orange flowers had a bittery quinine punishment. Okay? So what they did was that the bees were allowed to observe the conspecifics, and when the conspecifics were on the green flowers, they would learn to visit those green flowers, okay, because they knew that they were associated with a tasty sugary reward. However, if they'd learnt that their conspecifics were associated with quinine flowers, they'd also learn to actively avoid them. Now, when you think about in nature, There are loads of reasons why that could be, right? So you might not want to go where your conspecifics are because they may have already eaten all the nectar in that particular flower. What's important though is that if there was no learning phase, they couldn't discriminate between the two flower colours, right? There was no way they could have known that all the green flowers had sucrose and all the orange flowers had quinine. So yes, this is second order conditioning because the bees are associating the flower colour with the conspecifics and the conspecifics with a particular sugary or bitter reward. Okay? Fantastic stuff. So that's my introduction to social learning. Next time we're going to be talking more about our imitation, one of our mechanisms of social learning, and we'll also be talking about culture in animals. Ooh, how cultural. Look at me. Look at me. Bye.